Hi, this is Joe Bolen, and today we're going to discuss the if statement, and we're going to look at how we control the flow of our logic of a program. So I've titled this particular episode, The Big If. Decisions, decisions, decisions. But for us, decisions are actually a great thing because it allows us to control the flow of our program logic. So based off of some very simple conditions, we'll evaluate those to be either true or false, and based off the condition, we will then branch our logic to do different things in our code. So let's take a look at the rules about those conditions and what Visual Basic has to offer us. I have on the screen the title Decision, Decision, Decisions because it's a very important part of coding Visual Basic, in fact all programming languages. We have in Visual Basic basically three different types of selection control statements. We have the single selection with the if-then statement. We have a double selection with the if-then-else, and there's a modified version of this called the if-else. And then we have the multiple selection with the select case. Now today we will not take a look at the select case example, but we will focus our attention to the single selection and double selection. And basically what we're looking for is, based off of what we have in that selection statement, if that condition or expression turns out to evaluate to be either true or to false. We can't have it evaluate to anything other than true and false. It'll be one or the other. And based off that condition, we'll then branch to do whatever we need to do in our code to satisfy our logic needs. So we look at our code, and Visual Basic gives us these relational or equality operators, and they're very simple. We've got the greater than symbol, the less than symbol, the greater than or equal, and the less than or equal, and then we have the two equality ones, equal and not equal. So as we see our code, the situation would be if I have a comparison in terms of x against y, and I want to check to see if x is greater than y, I'll use the greater than symbol. Likewise, I'll use the less than symbol for a smaller than condition. I might want to test to see if it's greater than or equal to y or less than and equal to y. Or I might just want to test, once again, with the equality operators, whether it's equal to y or whether x is not equal to y. So these are all we need to know to produce the branching conditions for our logic in our code. So let's take a look at the very simplest of code statements, the simple if-then statement. Basically, we're looking, saying, if whatever condition we have in here, whatever test condition we have, if it evaluates to true, then we're going to execute within it the statements that follow the then statement. And if it turns out it's false, we're just going to jump past it to the end if and then execute code that might follow sequentially afterwards. So only if this condition is true will we execute the statements that follow the then keyword on that. Then we also have the if-then-else statement. In this situation, if the statement is true, we'll execute the statements after the then statement. But if the condition turns out to be false, instead of jumping to the end if, we're going to look at jumping to the statements after the else. So in this case, I'll execute either these statements or I'll execute these statements on that before I get to the end if. So if the condition is true, the statements after the end will be executed. If the condition turns out to be false, then I'm going to execute the statements after the else statement on that. So this is our simple if-then-else statement that gives us the true or false condition for our logic in our code. Now we can have a little bit more complex version of the if-then-else statement by nesting those statements inside each other. So here's the basic one we had in the last slide. If this condition is true, I'm going to execute these statements. Then I'm going to jump down to the end if and execute code after it. But if it turns out this condition is false, then I'm going to go down to this statement after the else, and in this case I have another if condition, and I'm going to test that condition and see if it's true. If it turns out it's true, then I will go ahead and execute the statements after that end statement. If it's not true, I'll go to its else. In this case, it'll jump down and test another if condition. If that turns out to be true, I'll execute these, else I'll go to this statement. And so we see that we're doing a series of nested if conditions, and it turns out that it is true. I'm going to execute the statements right after the then statements, or I'm going to execute the statements after the else statements on that. And so we can branch in a number of ways finally to get through our code and then continue on afterwards. Now, this is a variation of the nested if then else statement. The if else statement, once again, if the condition is true, I'm going to operate and execute the statements after the then statement, keyword I should say. Otherwise, I'm going to go to the next statement after the else if, test it. If that's true, I'll execute these statements. Then I'll go, otherwise I'll go to this line and test it. Else I'll go to the else statement and execute these statements on it. So no matter what, I will at least execute these statements if I have false for everything else. If I have any one of these true, I'll execute those statements, then I'll jump to the end if statement and continue on with my program. So let's take a look at our code and see that in practice. So I have Visual Basic up on the screen, and this is the little program design that I have. I'm going to have a text box to enter in a number between 1 and 10, and we'll look at a situation later on where I don't enter in 1 or 10, through 10, and then a result output of what I have done based off the if condition statements within the program. So let's take a look at the code inside the program. I have option strict on, and I have my main form class coded, and I've declared it two variables. A number is integer that I'm going to process what has been put into the text box, and then I have a string variable. I called it a string, and its data type is a string data type, and I have already initialized it with the string empty statement. Otherwise it's a null string, and I cannot reference a null string, so I have to initialize it with the string empty in this case. Now as we come through our code, we'll take a look at the number text box, looking at its text property, and based off of what is entered in there, if it can be converted to a number, then it'll be tested and converted to an integer using our number variable, using our integer try parse method to process our string that's in the text property of the number text box. So we come through and we've got it now in a numeric data type, and we're going to now use our if statement to test what we've entered. In this case, I'm just testing to see if I entered the number 5. If I didn't enter the number 5, then this condition will not be true, and I'm going to go to the condition after the end if statement. In this case, I'm going to go to assigning to the text property of my result value label a string. Now, since I didn't assign a value here, I have basically the string empty statement up here with a empty string that I'll be writing to my label. After I write to the label, then I'm going to put the cursor back into the number text box for the next entry. But you'll see that the only thing I can get into that output is when I enter in a 5. Otherwise, I'll have nothing in the result label that I'm using. So let's see this one operate. I'll hit the start button or F5, and we'll see our program compile and begin its run. Hopefully begin its run. There, I got a little problem. Let me try that again. There we go. A little bit of a problem that occurred there. So I'm going to enter in a number. This time I'm going to enter in a value of 4, which is not 5 for our test condition, and hit submit. And nothing is written to this box. But now I'm going to enter in the number 5 and see what we get. And I get you entered a 5. And that's exactly what we want to see happen. If I enter it in, for example, 6, this would go blank, which it did on that. So we see this program working as we've coded it. Now let's make the condition a little bit more challenging. And I'm going to bring in a boilerplate of a if-then-else statement. I'm going to copy it in and drop it into our program on that and replace it. Now we see the same thing, but now I'm testing. You entered a 5 just as before, but if I didn't enter a 5, then I have the else. So I'm going to go execute this if I didn't enter 5, and basically I'm saying you did not enter 5. And that'll be my output for my label. So let's run this one. Okay, let's enter in first of all 5 to see that one work. And in fact, it says you entered 5. Now let's enter in something other than 5, and I'll enter in 9. And it says you do not enter in 5. And that's exactly what we want to see happen. So there we see a situation of using the if-then-else as a decision making for our logic. Let's bring in another example, and this time we're going to use the nested if-then-else. Copy that in and drop it into our code. This time we're going to once again test for 5, but if I don't have a 5, then I'm going to say if the number was greater than 5. If it's not greater than 5, I'm going to go to the else statement and say you entered a number smaller than 5. So it's either going to be greater than 5, less than 5, or you're entered in 5. And that'll be our value that we put in a string and then assign it to the text property of our result value label. Let's run this one. Okay, let's enter in first of all 5 to see that work. And I entered in 5 and got that. Now let's enter in something less than 5. I'll put in 3. And it says you entered a number smaller than 5. Now let's enter in something bigger than 5. I'll enter in 7. And it says you entered a number greater than 5. And that's exactly what we coded in our logic. And so we see by using the nested if-then-else statement, we can test our logic to see all the possible values entered in. Now let's go even further with our design and use the else if, which is just like what we had before with the if-then-else nested type of approach. And we'll see how this looks just a little bit different, but does exactly the same thing. And here we see, once again, if I enter in 5, I'll have it, you entered a 5. Else if now, I'll test if you're greater than 5, else it's smaller than 5. And so it's the exact same logic, but now we're using the else if statement to make it a little bit tighter, easier to read code in our decision-making process. Let's run this one. Once again, it should do the same thing. I'll enter in 5 and get that. Now I'll enter in something less than 5. I'll put 4 in. It says you entered a number smaller than 5. Let's go something bigger than 5. I'll enter in 6. And it got you entered a number greater than 5. And that's exactly what we wanted to see happen in this case by using the else if statement versus a nested else if or if else then statement. Now let's go to the total solution for this particular program if we were going to write it, and that's to test all possible values. So I'm going to copy this one in and paste it into our code. It's essentially the same with a little addition to it, and I'll point that out to you. This time we're going to use what's called a short circuit logic, as well as the else if example that we had before. This time though, what happens is, if it turns out I enter a number that is less than 1, I'm going to have to come over here and test to see what I entered. Let's say I entered in a 0. Well, this would be true, and I wouldn't have to go any further. This would be a true statement, and I would say you entered a value outside the range of 1 to 10. Well, what if I entered in 11? Well, this would be false. So therefore, I need to come over here to the other side of the or else statement and test it. In this case, if it was 11, that would be false, and that would, in this case, or I should say, it would be true. 11 is greater than 10, and I would execute this statement. So basically, I'm checking to see if I'm outside my range with this. Now, I could have used just the or statement like that, which is an older way of coding. The trouble with this is I would have to test both conditions no matter what. But by using the or else, I do a short circuit. Now, there's another type of short circuit other than the or else. It's called the and also, and we'll see that later on in our coding. But this is the quick way to test for whether I'm outside the range. Then I'm going to use my normal else if conditions to test the rest of my possible values that I'm entering in. So let's run this one. This time, let's enter in 5 to begin, and I should get you entered 5, which I did. Let's go with something that's within the range of 1 to 10. You enter a number smaller than 5. That's right. Now let's go with something a little bit bigger than 5. I'll enter 8. You enter a number greater than 5. Now let's go outside the range of 1 and 10. Let me enter in 0. And I get you entered a value outside the range of 1 to 10. And I'll put in 10, which is right in my range. And I'll get you entered a number greater than 5. That's okay. But if I enter in 11, which is outside my range, I'll get you entering a value outside the range of 1 to 10. So our program now fully tests the logic on possible values that we can enter in. And we can see how we can use the short circuit method as well as the else if to make a nice condensed decision-making tree of logic of how our code could execute. Now, while we only have one statement after each of the conditions, we could have a series of statements or branch out with other routines that we need to execute. So it can be a lot more than just one statement being executed if our decision making is true or false on that. So I'd like you to practice the if then statement. Get very comfortable with it because you're going to be using it extensively as you code Visual Basic code. In fact, any computer code will be using extensively the if-then logic because it's an essential part of programming. We're testing to see if something's true or it's false. And based off of whether it's true or false, we make a decision of our flow of our code, how we're going to do something on that. So practice the if-then statement, then get a little bit more complex with the if-then-else, and then finally get the nested if-then-else, and maybe go to the else-if statement to make it even more condensed and easier to read on that. And then later on we'll learn more about using the short circuit statements of the and also and or else statements as well. But get your hands into the code, get dirty with it, learn how to use those statements, and you'll be glad that you'll be confronted with those big if statements because it'll give you control over your code and what you want it to do. So until next time, get your hands dirty in the code and take care.